In the last few decades, the agricultural sector has undergone significant transformations, owing much of its progress to technology. Among these advancements, precision agriculture stands out as a game changer. By using technology like Internet of Things, farmers can now monitor, analyze, and optimize the use of their resources to increase efficiency, productivity, and sustainability. This shift towards precision farming has the great potential to revolutionize the agricultural sector of India, a country where agriculture remains a key driver of the economy and livelihoods for millions. Today, we will discuss about precision agriculture, its methods, advantages, limitations, and government schemes. Hello folks, welcome back to my YouTube channel. Let's get into today's topic. What is precision agriculture? Precision agriculture, also known as smart farming, is a modern farming management concept that uses technology to monitor and optimize field operations by utilizing technologies like IoT, sensors, GPS, drones, satellite imagery, big data analytics, and so on. Precision agriculture enables farmers to monitor and manage crops, soil, water, and machinery more efficiently. In precision farming, the goal is to use data-driven insights to apply the right amount of inputs like water, fertilizers, and pesticides at the right time, in the right place. This practice reduces wastage, increases productivity, minimizes environmental impact, and boosts overall farm profitability. The Internet of Things, or IoT, refers to the network of connected devices that collect and exchange data. In agriculture, IoT technologies enable farmers to gather data related to soil moisture, crop growth, nutrient availability, and more, in real time from sensors, machines, and environmental monitoring devices. The collected data can then be analyzed to make better decisions about resource allocation, crop health, irrigation, and pest control. Here's how the Internet of Things, or IoT, is changing the way farming is done. Sensors and IoT devices. Sensors placed in the soil can monitor moisture levels, temperature, and pH, while environmental sensors can track weather conditions. This real-time data allows farmers to optimize irrigation systems and apply fertilizers or pesticides only when necessary. Drones and satellites. Drones equipped with cameras and sensors can fly over fields, collecting high-resolution images and providing detailed information about plant health, pest infestations, and soil conditions. Satellite data can also help monitor crop growth over large areas. Automated machinery, IoT-enabled tractors, harvesters, and sprayers can perform tasks with high precision, ensuring that only the required amount of fertilizer or pesticide is applied, thus preventing overuse and reducing environmental damage. Data analytics and cloud computing data collected from IoT devices can be sent to cloud platforms, where powerful analytics tools can interpret the data. This allows farmers to receive insights into field conditions, allowing them to make informed decisions. Methods of precision agriculture. The implementation of precision agriculture involves the use of several innovative methods. These methods enable farmers to optimize their inputs and enhance crop yield. Below are some of the core methods employed in precision farming. Variable rate technology, or VRT, uses GPS and sensor-based technology to apply inputs like fertilizers and pesticides at varying rates across the field, depending on the specific needs of different areas. By applying these inputs based on real-time data, farmers can reduce waste and increase crop yield. Geographic Information System, or GIS, technology helps farmers map and analyze spatial data related to their fields. It allows for the precise mapping of soil health, crop growth, and other vital factors. GIS enables farmers to create detailed field maps that guide them in making data-driven decisions. Remote sensing involves using satellites, drones, and other remote sensing devices to collect real-time data about field conditions. Remote sensing helps farmers detect crop diseases, nutrient deficiencies, and other issues that may not be visible to the naked eye. Global Positioning System or GPS technology allows farmers to track their location and the position of equipment with high accuracy. It ensures precise operations like planting seeds, fertilizing and harvesting, leading to reduced overlap, minimized waste, and efficient resource use. IoT-based automated irrigation systems use sensors to monitor soil moisture levels and weather conditions. These systems can trigger irrigation when needed, helping to conserve water and ensure crops receive adequate moisture without overwatering. All data collected through IoT-enabled sensors, drones, and satellites are aggregated and analyzed using advanced software and artificial intelligence. Farmers can then make informed decisions about when to plant, irrigate, fertilize, and harvest, ensuring better crop yields and more efficient use of resources. Advantages of precision agriculture. Precision agriculture offers several advantages that can help farmers increase productivity, reduce costs, and promote sustainability. Let's explore the key benefits. Increased efficiency and productivity. By using real-time data and advanced technologies, farmers can make informed decisions about resource allocation. This leads to better use of water, fertilizers, and pesticides, which can significantly boost crop productivity. Reduced costs. By applying inputs more precisely, precision agriculture minimizes waste and reduces input costs. For instance, using variable rate fertilizers helps reduce over-application, resulting in cost savings for farmers. Water conservation. In water-scarce regions like India, precision irrigation systems powered by IoT can optimize water use. Farmers can irrigate crops based on moisture levels and weather forecasts, reducing water wastage and improving crop health. Sustainability and environmental impact. Precision agriculture helps reduce the environmental footprint of farming. By minimizing the use of chemical fertilizers and pesticides, farmers can reduce pollution and preserve soil health. Additionally, precision farming methods contribute to carbon sequestration and soil restoration. Improved crop health and quality. Through continuous monitoring, farmers can identify issues like diseases, pests, and nutrient deficiencies early on. Early detection helps prevent widespread crop damage, improve crop health, and increase overall yield. Data-driven decision-making. Precision agriculture fosters a more data-driven approach to farming. This leads to better decision-making and long-term planning, helping farmers optimize their operations for profitability. Traceability and transparency. The use of technology makes it easier to trace the source and journey of agricultural products from field to consumer. This provides consumers with more confidence in the quality and sustainability of the products they purchase. Limitations of precision agriculture. While the benefits of precision agriculture are clear, there are also some limitations that must consider. High initial investment. The adoption of IoT sensors, drones, and other advanced technologies often requires a significant initial investment. This can be a problem for small-scale farmers, especially in developing countries like India, where the majority of farmers are small farm holders, and they have limited access to capital. Complexity and skill requirement. Implementing precision agriculture requires a level of technical expertise, which is not available at the farmer's level. The use of IoT devices, software tools, and data analytics may require farmers to undergo training and invest time in learning new technologies. Data overload. With the large volumes of data generated by IoT devices and sensors, managing and analyzing the data effectively can become challenging. Farmers may struggle to interpret and act on the data without adequate tools or knowledge. Connectivity issues. In rural and remote areas, internet connectivity can be unreliable. Without stable internet access, the full potential of IoT-based precision agriculture cannot be realized, as many technologies rely on cloud platforms and real-time data exchange. Maintenance costs. IoT devices and sensors need regular maintenance, calibration, and sometimes repair. These maintenance costs can add up over time and may pose a financial burden on farmers. Indian government schemes to promote precision agriculture. Recognizing the potential of precision agriculture in transforming the agricultural sector, the Indian government has launched several schemes and initiatives to promote the adoption of modern technologies. Pradhan Mantri Krishi Sinchai Yojana, or PMKSE, focuses on improving irrigation infrastructure and promoting efficient water management practices. Under this scheme, the government supports the adoption of automated irrigation systems that use IoT sensors to optimize water usage. National Mission on Sustainable Agriculture, or NMSA, aims to promote sustainable agricultural practices that focus on soil health, water conservation, and the adoption of modern technology. The mission encourages the use of precision farming techniques, including the use of soil health sensors and drones for crop monitoring. Soil Health Management, or SHM, scheme promotes the use of modern technologies like soil sensors to monitor soil health and apply fertilizers more efficiently. It is an important step toward reducing fertilizer overuse and ensuring sustainable farming practices. Farmers Producer Organizations, or FPOs, scheme. The FPO scheme helps smallholder farmers come together to adopt collective farming practices. These organizations can pool resources for the purchase of precision farming equipment and technology, thus making these tools more accessible to small farmers. Atal Innovation Mission, or AIM. The government's AIM initiative supports innovation in agriculture, including the development of IoT-based solutions for farming. Startups and entrepreneurs are encouraged to develop and deploy new technologies for precision farming. Digital Agriculture Mission. The Digital Agriculture Mission aims to promote the use of digital technologies, including IoT, for data-driven decision-making in agriculture. The mission supports initiatives that help farmers access real-time weather data, crop health monitoring, and precision irrigation. So, precision agriculture powered by IoT is transforming the way farming is done, offering the promise of increased productivity, reduced costs, and sustainable resource management. By harnessing the power of technology, farmers can optimize their operations and make more informed decisions, ultimately improving their livelihoods and contributing to the broader goal of food security. In India, the government has recognized the importance of adopting modern farming techniques and has implemented several schemes to support the transition to precision agriculture. Despite the challenges, including high costs and technical complexity, the future of agriculture in India lies in embracing these innovations to ensure food security and sustainability for generations to come. As the world faces growing concerns over climate change, resource scarcity, and an increasing global population, precision agriculture using IoT may hold the key to a more resilient and sustainable agricultural system. If you like the content, please give a thumbs up and share the video with your friends. To get notifications of my channel, please do subscribe and activate the bell icon. Thank you for watching.